My name is Guillermo. I'm part of the OCI Developer Evangelist team. With me, it's Andrea. He's the OCI Developer Adoption. He's in the engineering. So what he builds, I usually go and showcase to you. And we brought here a solution that we've had this pandemic over the last 2 years, so it's nice to be back on in-person events. And one of the things we used to do was to build demos with customers. But we built very big demos with Legos, smart cities, and stuff. And we were thinking on how we can reach more people in less time. And we came with this solution of building a portable demo. You can run different kinds of things, and we will see some of the use cases for healthcare, automotive, and banking. Today, we're going to show the banking one. It's just a bunch of ESP32 microcontrollers with Raspberry Pi and everything connected to the cloud. And we will see some of the services we are using to do the streaming and connection with the devices. So why the Suitcase? Basically, we say here mobility and stuff, but it's how we reach more people in less time and how we can ramp up a demo in less than 10 minutes and start showcasing the value of the cloud. Huh? This is how it looks, the big Suitcase. We used to travel with a bigger one, and then we decided, we should make it smaller and just pull it in the backpack. So this is the one that you're seeing today here, has the same amount of elements. The router is just outside, so when we design the whole thing is how we generate events in the physical world with Internet of Things and IoT. The whole thing is how we process and analyze that data and give you back the results. Huh? So what you're going to see today is these little controllers. Andrea will have one, I have another one. They have different profiles. One will be a silver program, the other one be on the gold one. And what we're going to do is how we reach out to the bank. It has like 3 buttons, and we will showcase on the first that we are near the geofence, the second one we are inside the bank, and then we use the ATM, the card on the ATM. And we will show up the whole thing once we connect to show you the demo, how the different elements will show the logs, the results, and the status, and then we will navigate on the console of the cloud to showcase in a map how we're getting close to each side. Huh? So these are a bit of the components. Raspberry Pi, we're using the version 4, which is out of stock in many sites with the pandemic. We are using the microcontrollers, some sensors, and the connectivity is a 5G router that allows you many things, and it's the one that's going to bridge us to the cloud. Huh? Oops. Again, software, we are using C, C++, and Arduino for the sensors, and then we are using Node-RED and Mosquito to do the publisher and subscriber model on the messaging side. Huh? From a cloud perspective, 6 different services, streaming obviously to get the whole thing, and we're using API gateway and functions to give back the outcome of the results and the output there. We are building in the OCI compute. It's just an instance where we have the MQ2 deploy and using stream analytics with Golden Gate to move things from one side to the other one. Huh? It's available in the marketplace, so you just can download and pull it there. Huh? This is a bit of the architecture, very simple. As you can see, the IoT connects to the Raspberry Pi. We use the router. Can you show the router here? This very nice Netgear will connect us to the cloud. We build the bridge and use the streaming there. MySQL is used for the different profiles. No, I have one of the silver or gold. I don't know what today I will have, and Andrea will have the other one. That is where we're going to query and see what kind of profile the user has in the solution. No? Oh, this is about stream analytics, how we build the whole thing with streaming, reference, the engine, and the outcomes there. But I think it's much better if we see it. I think it's more, no, sorry. Now it's better, huh? As you can see, there's a Suitcase with the geofence. We just get a couple of flows. If you are entering the geofence, it sends the rules. If you are inside or near, says the other one. And the only one that really makes something is when we do the MySQL stuff to get the profiles of the users. Huh? But I think we should just go and demo.
Why not? Yeah. We are ready.
Yeah, well, let's use cases.
Let's switch the cable.
3 use cases that you can do. We can use it in healthcare, for example. Now we can monitor patients, and we can use ML AI in the cloud to give back results. For example, when you need to get the right pill or when you need to see some of the results there. Banking is what we are going to show today. And automotive, it's more on on the telemetry analysis for predictive maintenance in the production chains. Obviously, you can have many, many more use cases. With the explosion of 5G, we will see an exponentially growth on IoT, and new solutions will come up into the market. And now I can probably disclose one thing that we're going to announce next week. We just validated ARM has a solution called virtual hardware, where you can emulate SOCs without having the boards and the farms. So now you can run Cortex M55 and Ethos U55 directly in Oracle Cloud, so you can run as much as simulations you want without really having the availability of the hardware. I think it's a good thing of how we are ramping up in this IoT world. But let's just move to this one. Huh? Better.
Oh, okay. So this is our Suitcase. So as G already mentioned, you can see the different sensor. So, and let's start. This is the Raspberry Pi. The monitor now on the Raspberry Pi will just show you is in a pub sub MQTT connected. This is running Mosquito. So basically, it will just be a sort of log of what's happening. Those are the main sensor that we are going to use for the demo. So let's start from the black one. This is actually the sensor that is going to simulate all the action. So we will use the sensor both as a simulator for IoT device when we are at the ATM in a bank, but also as a sort of IOP, Internet of People or Person. So basically wearable. Of course, now we don't have any wearable here, but that's the idea. So basically this is what will allow us to detect when you are getting near to the ATM and when you're entering in the geofence. We will show later how we built the geofence. The geofence we built in the Stream Analytics is basically going to represent a bank somewhere in Italy, in Rome. I put there. And you will see that different sensor will represent the people that are getting close to the bank, entering in the geofence and activating the different scenario. The white sensor is our monitor. Basically, the white sensor is the one that will allow us to see what's happening, that will get back the signal that is coming from the cloud. So connected through still MQTT and coming back. And the orange one is just logging the JSON request. Very simple for now. Of course, is a demo, but that's the JSON. You will see also inside the JSON there are the enriched data that we are going to provide through the MySQL as G described. And then we have the event billboards, this e-paper style, and it's just going to log all the calls. But let's see if everything everything works, because I just finished to build it. So I'm going to simulate entering so getting close to the geofence. Okay, so basically you can see that when I push the near button in the Raspberry Pi screen, you saw the JSON passing through the MQTT. The message go back into the cloud. Stream Analytics analyzed the message, recognized that this is an Internet of People kind of message, so coming from the user and the wearable, and is sending back a message, still using streaming and the MQTT bridge to the Suitcase, so to the edge, and the message that we see on the white sensor is okay, user near the geofence. Of course, the event billboard is signing this. Now we are going to enter in the geofence. And we are inside the geofence now. At this point, and we will show later in the map, when we are inside the geofence, of course, depending on the way you are enriching the data, you can activate different kind of function on the cloud side, depending on the activity that you want to provide.
We can use economic behavioral patterns. So when you get into the geofence, we know who you are, and we can provide custom products and from loyalty programs or whatever to really provide a custom experience for the users using the ATMs. Huh?
And finally, let's insert our card or maybe use some kind of contactless device just to simulate the message from the operator.
And we can use bank fraud detection models, saying that you got your credit card and we are putting there, but because of the IoT is not coming from the same device that you have registered in the bank. So now we can say someone is pulling money, is not the right person. I didn't record anything because of policies of protection, GDPR and stuff like that. But using the IoT device, I can detect if you are just stealing the card and getting money from someone else. Huh?
In this case, I'm a promo silver, so basically, and this is where the enrichment is actually working. We will see later in the pipeline. Basically, the same message that is coming from this sensor, and this sensor is containing the same JSON. The only difference is the user. I have a specific user ID. He will have a different user ID.
Yeah, let's go. Okay. Yeah, I'm gonna get near the geofence, so you will see it there. I'm gonna get, let's enter. There it goes. And now I'm going to use my card. And here in my card, it's gonna say that I'm better than Andrea. I have the gold one. Huh?
Yeah.
Oh, I'm the promo gold.
Yeah. As always, you got the better one.
The better toys to play, huh?
Okay, and basically, of course, now it's just silver and gold, so it's the only difference that we see now is in the sensor, a different background, a different right. But what you can do is really provide a specific, very customized service based on the different information that you are collecting from MySQL. Now, we use MySQL, can be, of course, whatever other database. You can use the autonomous, you can use different data store in the backend. Let's maybe switch on the
map.
On the pipeline, so we can see the map pipeline and then the map. Or do you want to show the map first?
Oh, the pipelines. Yeah, we'll go with the pipelines. And
okay.
Because the map is really small, blue, red. You see there we had heartbeats also. That's one for sports.
Okay, so this is the pipeline. So just let's take a look and see how the pipeline works. So we have two main pipe in the pipeline. I can find a better word to say that. One that represents the user. So when the user is getting close or the user is entering in the geofence. And in this case, the user basically will, wearing whatever kind of device, basically will notify the controller that is getting close or entering the geofence. The pipeline that is managing this is the one here at the bottom, sorry, without mic. Anyway, you see the geofence, and we will see how the geofence works. And depending on if you are near or entering the geofence, there are different rules that basically will, in this case, will just provide a different feedback to the white microcontroller. Very simple. In this case, we don't need really to enrich the data. We just need to make sure that we are controlling where the user is and when is approaching the bank. One thing that is important to highlight is that the geofence implemented in the stream analytics comes with additional logic. So basically, it will make sure that if you are already entered inside the geofence, won't be notified 2 times in a row. Of course, you are already there, so it doesn't mean for you to continue to have multiple notification. And similar kind of additional value or value-added function that you don't need to implement on your side of the program, but just you can get from the stream analytics. The other pipe that we get is the one that represents the hardware, so the ATM in this case, and is the one on the top. And this is where also the data enrichment is happening. So basically, when you are inserting your card in the ATM or contactless, are recognized by the ATM based on your ID. Stream Analytics will query the database, in this case MySQL, will extract the information of your profile and will enrich the profile based on, in this case, promo gold and promo silver for me. So this is kind of the kind of enrichment. This is mainly the pipeline. You want to add something?
Well, I think the good thing is about behavioral patterns, no? I can record the amount of times you go to the ATM and I manage, and let's say that I always get $100. Probably the 6th, 7th time I go, I will use ML AI to come and say, G always takes $100. So you will have that like the first option. So I'm really customizing the experience where you get into the ATM to manage based on the profile and the information that we have from you. You can also pick information from social media. We are seeing a lot of people things are for free, but you're putting a lot of information that you can track and include that as part of your behaviorals. Huh?
In the meantime, I opened the map so we can also show
it's
how
very
the
tiny.
geofence work. Try again when I are ready in my... Yeah, the blue arrow. Basically, the bank, now it's not showing for the column. Anyway, the bank is immediately close to where you see Poste Italiane. So we are now just close to them. And the red one,
that's me,
of course.
Yeah.
So basically, this is, and this is coming directly from Stream Analytics. So I just used the map. I designed my location to the bank. And when we are getting close, it's Streaming Analytics that, in this case, okay, now G
I'm
is
inside
the bank, and I'm still out. Now I'm going to enter the bank as well, and we are at in the same place. So basically, of course, then you can have multiple area, and then you can use the same geofence Stream Analytics function to help you to identify different location, and so to spread the same approach on different components.
This kind of solution helps in fraud detection. That is the main use case. When we see people get into multiple ATMs to get a fixed amount of money, that brings all the alerts into the bank, and we can use the wearables and the IoT to identify the path and the correlation of events. Huh?
Yeah, one thing that is important we didn't mention, of course, as part of the pipeline in the stream, we are interacting with functions, the serverless offering in Oracle Cloud. And I don't know if you have noticed before, but the first time I pushed the button, it was a bit slower. And this is the normal, what you expect usually when you are using serverless kind of function, because the first time that you're using it, the function is cold. So you need to spin up the Docker container via the scene in order to be able to fulfill the request. Of course, all the other requests that we did after that, the serverless was hot, and it was nearly real time the check.
I was going to say, if you want to ask questions in the meantime,
oh sure,
or you want to see something specific, just let us know. Huh?
Because of course, once the pipeline is published, you cannot edit it, so it's protected. And now that we unpublish it, I can go a bit more in detail and show you the different components. So let's see how the pipeline works. So basically, it's connected to the stream. So in this case, stream using the streaming service on OCI is a Kafka compliant service. So basically, is using the connector on the streaming analytics side that is compatible with Kafka. So, and the first filter is based on the user. So basically, recognizing in a simple way, you can see here. Okay, this is a user, so this is not the machine, this is not the ATM. It's a user that is sending a message. Once you have this part of the flow done, Then there is the geofence component, and the geofence basically is going to just look at the latitude and longitude that are coming from the sensor. The sensor are sending their geolocation, and based on the geolocation and on the map that I defined is the geofence component that will inject the logic to understand if we are close or if we are there inside or everything. At this point, it's just a matter of filtering by near or in this other case enter.
And you can play with the coordinates of the distance and how much time will be the user inside the bank, the average, before it logs or sends out another event. Huh?
And finally, there is the send. Okay, enter the rule is just setting the return status, and then there is the send to edge, and the send to edge is going to call the function. It's not calling the function directly, but we want to have the function, actually we expose the function through the API gateway. Because of course, in this way, we can provide an easy way to access the function without having the needs to use the SDK, but just with the REST call. So the API gateway service, still running on OCI, also running on OCI, is the component that allow you to expose the function. Now, in this case, the function through the API gateway is exposed in a private way, so it's just accessible from inside the environment that I built on OCI. So I have my network. The function is only accessible through that. Of course, you can decide to expose to external user, and depending on what the final use case and how you want to interact with that. The other part of the pipeline is when is not anymore the user, but at this point is the ATM that is the one that is sending the message. So you can see now as a filter, it is not anymore user, but it's ATM. And once the ATM is recognized, basically there is the profile enrichment. So the profile enrichment, you see here, the representation is not a great representation in Stream Analytics, but anyway, the green side are all the information that are coming from the sensor. So the ID, sensor problem, and all these kind of things. The orange one are the information that are coming from MySQL. So basically there is a match by the ID correlation condition there, user ID, dev ID. And last name, profile type, user ID are the information that are coming from the MySQL. This is the first level of enrichment. Then we have a second level of enrichment that in this case is called marketing enrichment. And is where we are basically using the profile type to get the message. The message for us will be promo gold or promo silver. That's basically it. Now, if I go back and publish the pipeline,
a moment for water.
It takes a few seconds. Okay, and I try to send the message. Okay, you will see that those are the information that are coming from the sensor, and this is the enrichment for myself. So promo silver and silver. So of course, in this demo, it's not a lot of information to enrich the data, but that's how it works. Now, if you try with yours, we should see promo gold because you are a different user. You need the red one, because now you are ATM. Okay.
There it goes.
See? Okay, and those basically are the two. And of course, the first level of enrichment put our names here, last name, first name, and profile type. And the second level of enrichment is for the marketing side.
Now you can leverage this with computer vision. If I have your identity, so I can check profiles, and when you are in the ATM, you can activate to see if it's a real person operating in the ATM. Huh?
And of course, if we look back at the VUL architecture, it's important to notice how so we try to implement the architecture in a way that is production ready. That yes. was something that we were discussing the other day looking at the VUL architecture. Because if you look at what we have in the Suitcase here, let me go back on my monitor. In order to do a simple demo, maybe we couldn't even use the Raspberry Pi. We could just have the sensor connected directly to the cloud. But every time you are going to have a real use case with IoT, with IoT scenarios, you will have a sort of a centralized logic also on the edge side. And this is where the Raspberry Pi is coming in the picture. So the Raspberry Pi here is representing this central logic on the edge, and is running Mosquito, that we are running also in the cloud, and we are using Mosquito bridging the queue. So in this way, it's an easy way, a seamless way to really provide the connection between the stream that you are running on the edge side and the stream that actually is managed on the Kafka compliant service in the cloud.
And now with the ARM virtual hardware, you don't even need to have the hardware. So I can emulate a chipset and do the same thing directly in the cloud, test it, validate it, and then push that into production into my IoT devices.
Once more, the thing that one other thing that we didn't that we can highlight on this scenario is that we try to provide. So when we build this full scenario, what also we wanted really to do is show how simple it is and to really have with a simple set of JSON information that are in a wearable, because of course if you need to work with a wearable, one of the main constraints is the amount of memory, and so the amount of information that you can have. So it needs to be minimal. So all the enrichment information would need to be in the cloud, need to be on the side where you can really have all the logic, complex logic, and complex amount of data. Because if you try to move that on the edge side, and this is a typical error that can be done when you're starting to implement IoT service, the risk is that actually you have two main risks. One is that you are going to get out of sync pretty quickly. And the second one, that even more dangerous, is that over time, when your service is going to grow, and maybe you want to add additional information, you will be in a situation where you don't have any more resources to do that. So that's why it's important to really isolate the two areas and make sure that the areas can work well together, but that you have all the relevant information on the cloud side, or anyway, on the remote side.
This was the tiny demo. We have a bigger project that is connected cars, that using Jetson Nano, I can turn the car into my wearable. So I can go to petrol stations and pay without leaving my car. If I go to a takeaway, the car will pay on my side. It's using biometrics and other information there, but the concept is the same as you are seeing here, but in a larger scale. Huh?
Yeah, in that case, our black sensor will be maybe a black BMW.
Yes, the big car. Huh?
But anyway, that's the case.
But the concept is totally the same. Huh? And this mix of virtual hardware in the cloud plus IoT sensors gives you the whole environment to really test and scale, and mainly accelerate the pace on the industry. getting new solutions, new designs, and use it for different industry verticals. Huh?
One other evolution of the project, and then maybe if you have question, let's maybe start with the question. But anyway, another evolution of the project is to add a security layer. So basically, what we are working on is connecting an additional sensor, a smaller one, again that should be a wearable, just to exchange the token with the Vault service in the cloud. So basically, you are going to keep the secrets and all the information in the cloud, in the Vault, secured, and just unlock functionalities based on the information that are coming from these additional wearables. Of course, this become more and more important if you want to provide a different level of service based on the kind of user. So maybe, I don't know, you want to activate specific function, function that can be done on the ATM just because he is gold, and I cannot access to that. So of course I need to have a way to protect the string of information and to make this even more stronger in terms of security layer.
Crypto trading, for example.
Yeah. Of course, then when you are going to talk about a connected car, this is going to be even more important.
Yes.
So that's the way we are trying to extend this approach.
Yeah, we'll make this available, this demo, so with the list of bill of materials. So if you want just to go and buy it, it's not a very expensive solution.
Yeah.
It would be really great to see some new ideas coming, and we should just throw out a challenge there and build.
Yeah, why not? Yeah, if you have any idea to extend it, that would be great. And yeah, as you mentioned, it's basically if we are not considering that now the Raspberry Pi is very expensive because it's impossible to find. But actually, those sensors are maybe 60 euro, all the sensor plus the case. So it's a really affordable project, but that can really help you to connect all the dots and see how the different flow of information are moving.
Yeah.
Okay, so I think we are ready for some questions.
Sure. We have a version that you use. There's a muscle breathing trainer that's called Aerofit. It's a startup from Amsterdam. One of the things we are embedding here is how we can detect heart patterns based on how you breathe and train with the application they have. So all these things can be used with IoT in different things like healthcare. So just giving ideas of the unlimited opportunities that you have with IoT, 5G, and having services in the cloud. Huh? Next time we should bring Boston Dynamics.
I've got here one question. That is, what's serverless role?
Okay, so the serverless role, it's important because basically will provide an easy and cheap way to send back the information from the cloud to the Suitcase.
Yes.
So basically, in this case, the serverless, we of course we could have implemented a service in using a virtual machine, but in this kind of scenario, it doesn't make any sense to have something running 24/7. But you just need to run the function when there is the need. So when I'm getting close to the ATM, when I'm entering the geofence, or when I'm using the ATM itself. And the serverless is perfect for this because you don't need to have any kind of infrastructure. You just pay for what you really use, and we saw that it's really fast. The only thing that you are going to pay in terms of performance is the first request. But of course, on a distributed environment, this is going to be irrelevant as a downside.
Okay, so big applause, please.
Thanks.